See here, we are studied that solids classification. Solids are two types. It's very clear. One is crystalline. The second one is amorphous. Amorphous solids. Again, that crystalline solids, they are classified into four types. One is molecular solids. The second one is covalent or network solids. Okay. The third one is ionic solids. Okay. And fourth one is metallic solids. It's very clear. Now, in these molecular solids, again they are divided into three types. One is polar. The second one is non-polar. And third one is hydrogen bonded molecular solids. HB, hydrogen bonded molecular solids. Okay, this is about that classification of solids. Now in this question, a solid is melted at 273 kelvins. 273 kelvins means 0 degrees centigrade. It is melting point of solid. So at that temperature, and it is another information also they gave. It is a poor conductor or bad conductor. Bad conductor, and it belongs to what type of molecular solid they given. They are asked. It belongs to molecular solid. That is ice. Okay, is example. The answer is ice. So the ice belongs to molecular solid. Actually here options not there, ma. Just options are being like, the first option is ionic. The second option is covalent. Third option is molecular. And fourth option is metallic. So the answer is a molecular solid. Okay. Now let's see the second question. The second one is the constituent particles in carborundum. We know very well carborundum. Carborundum molecular formula is silicon carbide, SiC. Silicon carbide is a covalent crystalline solid. Covalent crystalline solid. Okay. So that's why the silicon carbide, the constituent particles are atoms. Now the correct answer is first one, the constant particles present in carborundum. So carborundum means silicon carbide. You have to remember that carborundum means silicon carbide, in which the constituent particles are atoms. Now let's see that third question. The third question, what they asked, a salt AB crystallizes in cesium chloride. AB means cesium chloride crystallizes, crystalline cesium chloride. In that cation and anion radius ratio, in the cesium is cation and the chlorine is anion. They are asked the radius ratio of cation and the radius ratios of anion in cesium chloride. We know very well, for solving this question, radius ratio and its coordination number and examples we are discussed in the tabular form. So according to that, cesium chloride has BCC crystalline structure or cubic crystal structure. Okay, so in this radius ratio is in between 0.732 to 0.991. So lower limit only we need to take. What is the lower limit? 0.732. Already I will tell you that in this case coordination number is 8. Additional information also I am giving ma. So cesium chloride has a BCC, body centered cubic crystal structure or cubic crystal structure. Its coordination number is 8 and radius ratio of cation and anion is 0.732. Means let's see the radius ratio of cation and anion. Next, coordination number and shape. Already we are studied this tabular form up to 0.15. Its coordination number is 2 and linear. Okay, it is very clear. Up to 0.125, coordination number is 2, linear, means the radius ratio below 0.125 is present, then we have to consider as a linear geometry and coordination number 2. So coordination number 2 examples already we know that, and this radius ratio is in between 0.15 to 0.225, in between 0.225. Then lower limit only you have to take, then its coordination number is 3, planar geometry, and the radius ratio of cation and anion in between 0.225 to 0.414 is present. Then the coordination number is 4, tetrahedral geometry, and the radius ratio is in between 0.414 to 0.732 in between. Then the coordination number is 6, octahedral geometry, example NaCl, the radius ratio of cation and anion is in between 0.414 to 0.732 and 0.732 to 0.9. Then the coordination number is 8, has BCC crystal structure or cubic crystal structure. Is more than 0.9, the coordination number is 12. It has HCP, hexagonal closed packing crystal structure. So this is the complete explanation related to third question. So in this question, what they're asking, the radius of cation and anion. The radius of cation and anion in cesium chloride is 0.732. So lower limits only we need to take for this case. So what is the lower limit for cesium chloride? Because cesium chloride coordination number is 8, we know that. That's why its lower limit is 0.732. Okay, let's see next question. Fourth question one. The fourth one, what they gave fourth one, the coordination number of oxygen and silicon in SiO2 respectively. Silicon SiO2 is covalent crystalline solid. Covalent crystalline solid, it is very clear. Now it is a network covalent crystalline solid ma, silicon bonding with oxygen and silicon, oxygen, silicon, like it is a polymer. So like the structure will be repeats. Already in first PUC, carbon and its fourth A group elements, carbon, silicon, germanium, tin, lead. In that group only we are studied about the structure of silicon. SiO2 structure we are studied. So like it will be repeats this structure. If you are observed that silicon, around the silicon, how many bonds are present? What is coordination number? Coordination number is nothing but nearest neighboring atoms or a total number of bonds is known as a coordination number. Now the each silicon is surrounded by 4 bonds. Surrounded by 4 bonds. That's why its coordination number is how much 4. And oxygen, if you are observed that this oxygen is surrounded by 2 bonds. So oxygen is surrounded by 2 bonds. That's why its coordination number is equal to 2. Now with respect to first what they asked, oxygen coordination number they asked, next silicon coordination number they asked. That's why the correct answer for oxygen it is 2 and silicon it is 4. That's why the correct answer is 2 comma 4. The correct answer is 2 comma 4. Okay, clear students? Now the fourth question answer is 3. Third option is correct. So oxygen coordination number is 2 and silicon coordination number is 4. Let's see the fifth question what they're asked. Fifth question, crystal systems. There are 7 types of crystal systems are there and crystal parameters. So 7 types of crystal systems present and crystal parameters. Parameters that also we are studied. What are the crystal parameters? 3 edge lengths and 3 axial angles. So here edge lengths and axial angles they given according to that belongs to which type of crystal system they are asked. If you observe that A and A value is 0.387 and B is also is equals to 0.387 and C is equals to 0.504. Means what it is? A not equal to B not equal to C. Means two edge lengths are equal. A is equal to B but not equal to C. And axial angles, alpha is equals to beta is equals to 90 degrees and gamma is equals to 120 degrees. Means like this crystal system arrangement is present in which crystal system? It is hexagonal crystal system. It is belongs to hexagonal crystal system. Okay, if A is equal to B is equal to C, alpha is equal to beta is equal to gamma, then it is called cubic crystal system. Cubic crystal system is more symmetrical and triclinic crystal system is there. Triclinic crystal system is more unsymmetrical because A not equal to B not equal to C and alpha not equal to beta not equal to gamma not equal to 90. That is called triclinic crystal system. So in out of 7 crystal systems, more symmetrical crystal system is cubic crystal system, more unsymmetrical crystal system is a triclinic crystal system. Here alpha is equal to beta is equal to 90 and gamma is equal to 120 degrees. That is the axial angles, and related to edge length A is equal to B not equal to C. It belongs to hexagonal crystal system. So the correct answer is second one. The correct answer is second one. Okay, clear? Now let's see that the next one, sixth question. Sixth question, let's see. What it is very easy, ma. Bragg's equation we know very well. Bragg's equation. What is Bragg's equation? The Bragg's equation, n lambda is equals to 2d sine theta. N lambda is equal to 2d sine theta. Okay, that is Bragg's equation. In this question, n is equal to, what is the order? First order diffraction means n is equal to 1. N is equal to 1. And what they are asked, ma, if they are asked what is the d value when d is equals to lambda and lambda by 2, 5 lambda by 2, they are asked at which theta diffraction angle we need to find out. So what are the theta values when d is equals to lambda and lambda by 2, at which what is the angle they are asked. So it is very clear, n is equals to 1, in which d is equals to lambda by 2 into 1 by sine theta. 1 by sine theta. We know very well sine theta values from 0 to 90 degrees. Means sine 0 is equals to 0, sine 30 is equals to, sine 30 degrees is equals to 1 by 2. Okay, if theta is equals to 30 degrees, then sine 30 degrees is equals to 1 by 2. Okay, therefore d is equals to lambda by 2 into 1 by 1 by 2, then is nothing but lambda by 2 into 2 by 1, then this 2 will cancel, then lambda is equals to d, or d is equals to lambda came. If d is equals to lambda, then theta is equals to 30 degrees. Theta is equals to 30 degrees. It is very clear. Next, second condition, let's see. The second one is what we have to find out when d is equals to lambda by 2. If d is equals to lambda by 2, then theta we need to find out. If theta is equals to 90 degrees, theta is equals to 90 degrees means sine theta is equals to, or sine 90 degrees is equals to 1. It is very clear. Therefore d is equals to lambda by 2 into sine 1 by sine theta, means if theta is equals to 90 means sine 90, lambda by 2 into 1 by sine 90 degrees is nothing but lambda by 2 into 1 by 1 is equals to lambda by 2. So therefore theta is equals to 90 degrees. Then d, interplanar distance between the crystal planes, is equals to lambda by 2. Okay, so if d is equals to, the sixth question, if d is equals to lambda, at that angle is equals to 30 degrees. If d is equals to lambda by 2, the angle is 90 degrees. Theta is equals to 90 degrees. The correct answer is a third option. Okay, clear? Let's see seventh question. Seventh one. Each unit cell of NaCl consists of 4 chloride ions, and how many Na plus ions present? Already NaCl crystal structure in regular classes only we have discussed. NaCl crystal contains or NaCl crystal, one unit cell contains total 27 ions present. 27 ions present, in which 14 are Cl minus ions and remaining 13 are Na plus ions. Remaining 13 are Na plus ions. See how it is. So first you draw the crystal structure of NaCl. So in NaCl, the Na plus ions and Cl minus ions are existing alternatively. Alternatively means at corners sodium ions are present, at edge center chloride ions are present, or at corners Cl minus ions are present, at edge centers Na plus ions are present. Like let's see. Like this is the unit cell structure of NaCl. Now here you made it like see this yellow color is not visible clearly. Again I am used red only. These points you have to connect down, and these points you have to connect here. Now take this corner is black color is chloride ions at corner, okay, and this alternatively chloride ions next Na plus ions. This red dot is equals to Na plus ions. Like you have to fill that total points, means alternatively here black, okay, again here black, and again here black. The remaining in middle place what it will comes, and here chlorine will comes, Na plus ions will comes. See here Na plus ion, again chloride ion and Na plus ion, and middle chloride ion will comes. Again here in middle two chloride ions in middle, Na plus ion will comes. Na plus ions here I symbolized red. Okay, now upper side over, and this middle part also you have to fill like, and bottom also you fill like. Then total how many ions present ma? In one unit cell of NaCl crystal structure having total 27 ions are present. Out of the 27 ions, 14 chloride ions and 13 Na plus ions. Otherwise, if you no need to remember this crystal structure also, but this numerical you have to remember carefully because it is very, very important. Okay, students, let's see 8th one. Next, an element crystallizes having FCC. Okay, and edge length is 200 picometers, and calculate the density. If 200 grams of FCC element having 24 into 10 to the power 23 atoms are present, then we have to calculate density. So for this formula, they are not given directly atomic weight of element, they are not given. So in this case, first we have to calculate density formula. D is equals to Z into M by A cube into Na. D is equal, that is the density formula. In the density formula, density we need to calculate for FCC. For FCC, Z is equals to unit cell constant is 4. Okay. And edge length A is equals to 200 picometers. This 200 picometers is nothing but 200 into 10 to the power of minus 10 centimeters, because 1 picometer is equals to 10 to the power of minus 10 is nothing but 2 into 10 to the power of minus 8 centimeters. Okay, it is clear. And Na, Avogadro number, Na is equals to approximately 6.02 or 6 into 10 to the power of 23. Now, but M we don't know. We need to calculate M. How to calculate? 200 grams contains how many ions are present? 24 into 10 to the power of 23 is present. But M means gram atomic weight. It contains how many atoms are present? Is always fixed 6.023 or 6 into 10 to the power of 23 atoms are present. Now M value calculate by doing cross multiplication, that M is equals to gram atomic weight of element is equals to 200 into 6.02 into 10 to the power of 23 by 24 into 10 to the power of 23. If you on simplification, we'll get how much will comes ma? 50 grams. 50 grams will comes. Okay, because this 10 to the power of 23, 23 will cancel. This 6 1 ja, 6 4 ja, and 200 by 4 is nothing but 50. Now density you calculate. All values know that density is equals to 4 into 50 by A cube, 2 into 10 to the power of minus 8 whole cube, into Na 6.02 into 10 to the power of 23. If it is on simplification, we'll get approximately 41.6 gram per centimeter cube. That is the density of given element as existing in FCC crystal structure. Then its density is equals to 41.6 gram per centimeter cube. Okay, but here directly we can't calculate, because that gram atomic weight they are not given. That gram atomic weight indirectly they given, because 200 grams of that element has 24 into 10 to the power 23 atoms are present. But what is the gram atomic weight? Gram atomic weight contains 6.023 into 10 to the power 23 atoms are present. Indirectly gram atomic weight we are cut. This is the additional step. After that only that molecular weight of atom we are substituted 50. Then 4 into 50 by A cube into Na. On simplification we are getting 41.6 gram per centimeter cube. Then the answer is first option. Important this type of problems. And among that, sixth problem also important. And one more is crystal system parameters. Crystal systems parameters means edge length, axial angles relations. That also very important. Directly they are asking in CET examination or NEET also, or in case board examination also they are asking. Okay, next let's see ninth question. Ninth question also very easy direct theoretical. What they are asked in the ninth question, sodium, okay, and magnesium they given respectively. Sodium crystallizes in BCC, sodium crystallizes in BCC, and magnesium crystallizes in FCC. Okay, then the number of atoms of Na and magnesium present in unit cell. Number of atoms in unit cell is equals to unit cell constant. Z is equals to, for BCC how much ma? 2. And the same way for FCC, Z is equals to 4. So the answer is 2 comma 4. Fourth option is correct. Okay. Let's see the next questions. 10th one. Let's see the 10th one, what they're asked. The 10th one is K plus and F minus. K plus F minus forms KF. KF is type of NaCl structure. NaCl structure. It is very clear. Now, in this KF, radius of K plus. Radius of K plus, how much they given? Radius of K plus is equals to 133 picometers, and radius of F minus they given has 136 picometers. What is the distance between K plus and F minus? Means imagine that this is potassium atoms are being like, and fluorine atoms. This is the nucleus of potassium, this is the nucleus of fluorine. This is the distance. This distance is nothing but radius of K plus plus radius of F minus. Means that is the distance between potassium and fluorine is equals to, between potassium and fluorine is equals to sum of the radius of potassium and fluorine is equals to how much? 133 plus 136 is equal to 269 picometers. So the correct answer is first one. Is very clear. Okay, let's see that. Next question, 11th one. 11th question. 4 grams of X is present. It is crystallizes in BCC. So how many number of unit cells? The number of unit cells is equals to number of atoms by Z. For BCC, Z value is 2. We know that. But how many number of atoms present in 4 grams? So how to calculate number of atoms means number of moles. 4 by 40 means weight by gram atomic weight into Avogadro number. Avogadro number symbol here N naught they gave. What is for BCC? Z is equals to 2 means 4 by 10. 10 times is nothing but 0.1 into N naught by 2. So the correct answer is third option. The correct answer is third one. Okay. In the same way, 12th question, let's see. 12th one, a metallic element has cubic lattice. Cubic lattice, each edge, the edge length of unit cell is 2 angstroms. The density are they ask. Cubic means simple cubic crystal. Simple cubic crystal. Then Z is equals to 1 and A is equals to 2 angstroms. 2 angstroms is nothing but 2 into 10 to the power of minus 8 centimeters. Okay. And the density they given, the unit cells present in 200 grams. A metallic element as exist in cubic crystals.